Hi, everybody. My name is Danila Petrelli, and I'm a linguistic resource developer at Recorded Future. First of all, can I ask you how many of you deal with text data or work with text data? Okay, well, that's good to know. I hope you're as excited about text data as I am, because I am quite a lot. And I am going to talk, and this is also going to be the main focus of my talk, the Christmas market effect, a case of overfitting that happened during the training of a text classifier. First of all, I want to say that it's a very joyful title, but the domain is quite serious, so bear this in mind. And I'm going to talk about what we do and what was the project that generated the effect, what we expected, what we didn't expect to encounter, the solutions and future plans, and the conclusions. So, who are we? What does Recorded Future do? We provide threat intelligence. We fetch data from the web, analyze it, and then make the analysis available to clients. And this is mainly in the cyber domain, but also physical security, as you are about to see. And my team is most focusing on machine learning and NLP. And what I do is, for instance, I develop datasets. And this is going to be a bit of a journey into the building of a dataset. Okay. About the task. So what was the project that we had at hand? Create a terrorist incident detector. This is the reason why I said that this is a serious issue and a sensitive one. We take it seriously. This is a part of our physical security offer, and you can imagine that people can use a terrorist incident detector, clients can use it to assess risk in certain areas to protect their assets. And the goal was to detect reports of current terrorist incidents in data streams from social media and news wires. And they will look like the following. Suicide bomber kills 11 people in mosque attack in northeast Nigeria, sources say, or explosive-laden vehicle detonates outside crowded restaurant in Somalia's capital. So in order, as you can see, this is a binary classification task. And we decided to use a CNN as a model for this. And of course, the first step in order to build a detector would be to create a dataset for classification. Building a dataset also means to make sure that your classes are balanced and that they have the right amount of knowledge of the domain we are performing classification on. And when I say knowledge, this means that we are not concerned here about the numbers, the size of the classes, how much data is in the classes. It's about the knowledge and the way it is spread through the classes. So this is an overview of how the dataset looks now, but throughout the whole process, let's say that the proportions were still this one, so it looked similar. You can see the positives, general negative data, and negative edge cases. So if you're wondering what's the difference between negative edge cases and general negative data, it's because in the general negative, I really don't expect to find any language which is relevant to the classification. It's very far from being terrorist related, and no violence whatsoever in it. While in the negative edge cases, as we will see, there will be different examples of violence or something much harder to disambiguate. And the positives, you already saw some examples about it. What you can notice here is that we just have 6,000 positives, whereas we have 27,000 negative edge cases and 18,000 general negative. So in an ideal world, you would really like these classes to be balanced, to be of the same magnitude, right? But luckily, in the news about terrorist incident are not as frequent as the rest of the news. So this is reflect that. And yeah, so what we expected with a task like this, so of course we knew that we had to struggle, for instance, to find relevant positives. And except for that, also another expected challenge was to manage to disambiguate the general violence present in the news and in the social media, or reports about other kind of violence. So I needed to add to the negative data non-reports, armed attacks, which are not related to terror, traffic accidents, natural disasters, suicides, and so forth. So this is because linguistically this kind of data points can really overlap with the main task that we are going to do. Like the syntax is very similar, and so this is what we were doing. And in order to do so, we were trying to add data to the dataset. In this moment, we were basically fetching data from the web, getting it annotated, and then retraining and evaluating on real-world data to see how the performance of the detector was going. Yes, so everything seemed promising. Imagine that it was December 2018, last December. And our goal was to reach 90% precision, while at the same time for keeping an eye on recall, right? But we were very close to that goal. We were very happy about the way we could detect correctly, and so remember that we were in this process of retraining, at the data and retraining, and we thought we were doing good, but on December the 11th, the Strasbourg Incident occurred. I don't know if you remember, but there was a terrorist incident at the Christmas market in Strasbourg, and this news on the web had a very, very high presence. Just to give you an example, our system collected more than 10,000 mentions of this specific event. So what happened was that while I was in this process of retraining and adding data, I added data from this specific event to the dataset. So what we didn't expect was that this data polluted my dataset. And this is what we, inside my team, call the Christmas market effect. Basically, all of a sudden, our classifier was starting to detect with very high confidence the following examples. Amazing Red Square and Christmas market in Moscow. Christmas, let's say, jump in, the traditional Christmas market at Vienna. Gifts, luxuries, culinary threats, and traditional crafts can be found at Gothenburg's Christmas markets. So, of course, we immediately realized that this problem was caused by the last data added to the training. But what struck me the most was the complete lack of violence or terror-related indicators in these data points. It was really the word Christmas market here that was creating the issue. They all of a sudden gained a huge weight. And why did this happen? So, and the precision dropped to 73%. And remember that I was really close to my goal, which was 90%. This was a disaster. This happened because the Christmas market words were only present in the positive data. I had no clue that there was no mention of these specific words, not in the general negative, not in the edge cases. And yes, so this is what the classifier learned, that Christmas market was extremely related with terrorism. The other reason why the precision dropped so dramatically is that I evaluated on real-world data in December, and so the web was talking about Christmas markets a lot, the worst month to evaluate this classifier. But yeah, so we call it the Christmas market effect, but actually now we use this exact term within my team to refer to every case of overfitting. It happened already in this model in 2 other cases. So for the word minivan, for the word hotel, it can happen a lot. We still refer to it like to this problem with these words. But this product needed to be delivered, so we needed to find a solution for this. What did I do? What would you do? It's easy, right? So first of all, I thought about addressing the problem exactly as I did with the previous examples that I gave you about the general violence, right? Let's add more data to disambiguate, and let's balance the knowledge of the classifier. Let's push the decision in the right direction now. And the precision raised slowly from 73% to 85%, which is good. But it wasn't really what I was expecting. Also, it turned out to be a very slow process because you are not really sure if by introducing specific handpicked data, what other bias you're creating, what other you might be overfitting on something else. Also, it's not really clear if how much data, and are you gonna just teach the model about markets, about Christmas, the combination of those. It's complex. So I thought that I really wanted to go back to the moment in which actually we were performing so good. And I thought about simply removing the data that was causing confusion. It was not helping the classification at all. And the precision raised from 73% to 91%. And also, in order to feel confident about this decision, I decided to test it on the Christmas market-related data points. And I mean, the Strasbourg Incident. I wanted to know if my classifier was able to actually detect that specific terrorist incident without having trained on the Christmas markets words. And the answer is yes. We correctly detected. And I really think it's extremely hard to train on every possible word in a language, because the language is too sparse. So since we can't possibly do that, we might as well discard data, which is harmful. This is a future plan. This is an experiment. And unfortunately, I can't show you results about this because it's an ongoing plan. But I would really like to hear from you afterwards in the break, please, ideas about this. I'm gonna just say very few words about it. This is a learning system tutor that we are planning to develop so that this problem can be addressed programmatically. And this consists mainly in computing word statistics on the classification results and check if some words have a very high presence just in the true set, because we might think we might assume that they are the words that the classifier is using to make the decision. And once we have identified these Q terms, then we check their presence in the training data and in the general language, in a general language corpus, checking if there is a discrepancy. If there is, we might want to modify the training data accordingly, either by adding data or by removing if it's not of use. And there are many ways to address this issue that I talked about. This is our idea. We'll see. So just very fast conclusions. What I learned from this experience, since overfitting, overtraining on underrepresented words in a class is something that will occur again, and I'm sure that occurred to you as well, is that you should always inspect the data closely, because data is your friend, and the answer is there. You can get a sense of what's happening, and maybe not conclusively, but you might fix many issues. And then this is counterintuitive, right? Don't be afraid of removing data, but everybody who's building a data set is struggling with finding data to add all the time. But if some data is just not helping the classification, well, discard it and test it and evaluate on real world data what that means, what are the implications. The last thing that I want to say is to consider using data from a wider time frame, because any of you using working with time series data will encounter that data coming from the very, very close period in time might have a lot of, might create this problem very frequently. So just consider using a very, very wide time frame. So the language, the linguistics, everything, the features of the data you're using can be also diverse. And I'm saying this because I have really the feeling that if this specific overfitting case happened during February, this might have been called the Valentine's Day effect. And yeah, thank you for listening.
Great, thank you. Very nice. Do we have any questions from the audience? Anyone? So, oh, great.
Yeah, so regarding cybersecurity, you didn't mention that much about it.
No, that's true.
But how do you collect data for that? Because it's, figure it's quite difficult to be proactive about it. You could react to it and know what's happening and which groups are behind an attack or something.
Mm-hmm.
But are you aiming to be proactive, or what's your...
So, but you're asking, are we collect the data, or are we manage to do the analysis, like which data we perform the analysis on? Which is
both, I guess, but more collected, because it's not that open as terrorist attacks, for example, that is covered in the news. But it's a bit more, let's say, hidden information when it comes to cybersecurity.
So as I said, this is more part of the physical threat intelligence offer of my company, but the point is that this is supposed to detect very early stages terrorism, but on headlines of news wires and social media. And how we collect it, we fetch all the possible data in the web. This is, and then the hard part is to be able to distinguish and to discriminate over the data. But I am not in the data science team, and sometimes I think I'm really glad that I'm not, because it looks really hard to collect data. Sorry.
Wrong audience to say that.
No, I mean, I'm saying they are geniuses.
Great. So, any more questions?
Yeah. Hi. In the case when you remove data to sort of get to the result that you want, won't there be a risk of getting an image of the world that doesn't really correspond to the reality?
Mm-hmm. Yes, definitely. Everything you do with the data creates that risk, and you can't really predict it. But in this specific case, I basically removed the knowledge from the classifier that terrorist incident can happen in Christmas markets, but then evaluating it, I found out that there was enough general knowledge of what a terrorist incident was in the dataset for it to be able to distinguish it, because a headline will have a lot, like there is a structure, there is a lot of other violent language. So what I was avoiding by removing data was just to overfit. But that's a point. Yes, I think that's something we should keep in mind. That's a danger.
Okay.
I have one question.
Yeah.
So why do you focus on precision and not recall? Because it seems like for terrorist attacks you want to find as many of them, and then you can manually remove the ones that are actually...
Yeah, okay, so if I don't focus on precision, it's going to be a problem, because I'm going to get a lot of headlines which are not related. But the recall is incredibly important. It's very hard to calculate, actually, and because of the enormous quantity of data that the production data that we collect. But in terms of events we're missing, we are we out of time? Because we are trying to find very good ways to calculate the recall on this specific classifier, and we find out that there is a behavior between, there is a correlation between how, unfortunately, how much the news talk about an event and how likely it is that we detect it. We are working towards that, but the precision, we really want to be sure that if we are showing a terrorist incident, it is a terrorist incident.
Great.
Yeah.
Thanks.